Okay, welcome back everybody to 1.2. Let's go ahead and cover the next topic, revenue, cost, profit, and average cost. So, one of the main applications of using algebra with functions is concluding to the profit function. The profit of a company makes depends not on what they make per item, but also the cost of producing each item, right? So let's go ahead and go over some basic vocabulary of these types of functions. So there's a cost function denoted as capital C of X, and it's equal to the fixed costs plus the variable costs associated with producing X items. So the way the cost function kind of looks, it's linear. So it would look something like, you know, C of X would be like C of X equals V times X plus F. And what do these variables mean? Well, V just means variable costs, and F is just a fixed cost. Okay, just like the definition, fixed cost plus a variable cost per each item. Okay, so next function is the revenue function denoted as capital R of X. And this just tells us how much money will be earned by selling each item. Revenue depends on the price and the number of items sold. Okay, so a revenue function really looks something like, capital R of X equals P times X, where P is just the price per item. Okay, and X is still the number of items. So X will always just be number of items in these definitions. And, this would be a revenue function. And sometimes, I'll just make a quick note of that. Sometimes this is quadratic, meaning like x squared, right? X squared plus something x, things like that. So just keep an eye out for that. And lastly is a profit function is given to us here, but the profit function is just going to be revenue minus cost, right? If you think about business, it's kind of self-explanatory. Like, the profit is how much you're making minus how much it's costing. And one last term is kind of an average cost function. You might be unfamiliar with this. It's kind of the same as a cost function, but you see there's a solid line above the C. But this is just a cost function divided by the number of items. Okay, let's go ahead and apply these in an example. Okay, so we have a small family farm has started a business selling homemade bottles of olive oil at a local farmer's market. They spend about $30 to rent a local space or to rent a space at a local farmer's market for the day. Each bottle of olive oil consists of $4.50 to manufacture, and they sell each bottle for $12. Okay, so if X represents the number of bottles of olive oil sold each day during the day at the farmer's market. Okay, so we have a couple of things going on. The first question asked though, find the cost function, the revenue function, the profit function, and the average cost function. So all of these previous terms. So the cost function, just go ahead and get right to it. The cost function is what? It's your variable cost times the number of items sold plus a fixed cost. And what is our variable cost? So we see that each bottle of olive oil costs $4.50 to manufacture. So that would be our variable cost. It would be $4.50 times how many bottles we're selling. And what's the fixed cost? Well, if we it's not exactly stated, but it automatically spends $30 to rent the space. Like no matter how many things we sell or not, that will always cost us the same. So that would be our cost function. Okay, so now our revenue, right? What's our revenue again? Our revenue is price per item times number of items sold. So our revenue function, how much are we selling each bottle for? We're selling it for $12. $12 each bottle, right? So that would just be price per item times X. So it'll just be 12X. Okay, now profit. Profit's always the easiest one because it's just going to be your revenue minus your cost. And we have both of those. So this would be revenue is 12X and cost is 450X plus 30. Important to put parentheses around here because we got to distribute in this negative. So distribute in the negative, and what we end up with is 12X minus 450X minus 30. And if we simplify this, we should get we should get 7.5X minus 30. And that is our profit function. Okay, so last one is the average cost, right? So C bar of X. So remember, that's just the cost divided by the number of items. And that's just 450 plus 30. 450X plus 30 over X. And we could do some algebra to simplify this out a bit. You know, we're all on over one denominator, so we can separate that denominator out, like 450X over X plus 30 over X. And the X's cancel out, and we're left with 450 plus 30 over X. And that would be our average cost function. Okay, let's move on to part B now. How much profit will be generated if the farm sells 20 bottles of olive oil in one day? So we're talking about profit, right? So profit, remember we just found that it's 7.5x minus 30. All right, so we want to know if we sell 20 bottles. So 20 bottles is our number of items. So we're just going to plug in 20 and see how much money we make. So it would be 7.5 times 20 minus 30, and that's 150 minus 30, which is 120. Okay, so what does this mean in context of the problem, though, right? We're being asked a specific question. So it's always good practice, and I'll be asking you to do it quite a lot, but to write it in terms of the problem. So what I'll say here is if the farm sells 20 bottles of olive oil in one day, $120 of profit will be generated. Okay, so that's what that statement means. Okay, let's move on to the next one. Sketch a graph of the revenue function and the cost function. So what we're going to do is jump to Desmos, like use Desmos, and we're going to check it out, right? So let me jump to Desmos, and we're going to graph our revenue and cost function. So moving to Desmos, my revenue function is 12x, and my cost function is going to be 4, oops, y equals 450 plus 30. Sorry, 450x plus 30. Okay, so here's what it overall looks like. Let me kind of, our revenue is red and our cost is blue, and that's really what it looks like. Okay, so when we look at graphs like this, we really just want to look at starting at 0 because we're not going to have negative number of items. It doesn't make sense. So that's really what this graph kind of looks like. We have some type of intersection here. It looks like 448 in green. Okay, so let's go back into the notes and look at the next question. You might be leading on to something. So how many jars of jam must a student sell in order to break even? So quick note, if you're unfamiliar with the term break even, I could write it down here. I'll write it up here. Note, break even is when your cost and revenue are the same. So what that means is you would set your revenue equal to your cost, and you would solve for X. You would find the number of items that make your revenue and costs equal, meaning you're breaking even. So algebraically, let's check this out. So once again, it has to be when your revenue and cost are equal. I think I wrote this backwards as opposed to our side note. So revenue equals cost, right? So that means I have 450x plus 30 equals 12x. So I want to solve for x, right? I want to find the number of items that break us even. So what I'll do here is I will move the 450 over to the right side, right? So this guy cancels out. And so what I'm left with, I'm going to come up here, I'm going to have 30 equals 7.5x. And now I'm going to divide by 7.5 to both sides, right? Just a basic algebra that we reviewed. So 30 divided by 7.5, well, that is x equals 4. Okay, so what does this mean in terms of the context? Well, the student must sell 4 jars, or it says jars of jam, but it should be olive oil. Yeah, should sell 4 bottles of olive oil to break even. Okay, and that's the statement, right? So if we sell 4 bottles of olive oil, we will break even. Okay, so let me go back to the graph, right? We were checking out a graph. We looked at a point of intersection. What x value is this point of intersection? Well, that is x equals 4, right? Where their costs and the functions intersecting at is x equals 4. So that means that when it intersects, that's when you're breaking even at this point of intersection. That means they're exactly the same, and that graphically and algebraically you can tell when you are breaking even. Okay, so that's how graphs and algebra relate to costs, revenue, profit, things like that. Okay, so that's it for this part of the section. I'll see you next time. Thank you.